So for today's lesson, we are going to be learning about the scientific method. You have probably learned about the scientific method before. Different teachers and textbooks use slightly different versions of the scientific method. So this is the one I prefer. It has 7 steps, and they are observe, problem, research, hypothesis, experiment, conclusion, and communicate. Now, I will ask you to memorize these, but you're going to use something called a mnemonic device. And a mnemonic device is something that we use to make memorizing something easier. So that is spelled M-N-E-M-O-N-I-C, mnemonic. Kind of sounds like memory. Wikipedia defines it as any learning technique that aids information retention. Retention just means how well you remember something or retain it in your brain. So one mnemonic device that you're probably familiar with is please excuse my dear Aunt Sally. Please excuse my dear Aunt Sally. PEMDAS. You use that in math. And as you should remember, it stands for parentheses, exponents, multiplication, division, addition, and subtraction. Those tells you the order of operations. Now, I did make up a mnemonic device for the scientific method, and it is old people really hate eating crummy cupcakes. So, O, observe, P, problem, R, research, H, hypothesis, E, experiment, C, conclusion, and the next C, communicate. Now, one thing people think about the scientific method is that it has to be done in this exact order. And for it truly to be the scientific method, every step has to be done. This is not the case. Something can be considered to be the scientific method even if not all of the steps are used or if the steps are done out of order. And we're going to be talking about some examples of that later on. For now, let's go into the steps of the scientific method in more detail. And to go over the steps, I'm going to use the example from an episode of Mythbusters, the Diet Coke and Mentos episode. So the first thing is that you'll observe anything in nature. So what the Mythbusters observed is that when Mentos were put in Diet Coke, it caused a fountain of soda. The next thing the Mythbusters did is state the problem, and the problem was that they did not know what caused this reaction. Then the Mythbusters did background research, so they looked at other videos on YouTube and looked at the comments and looked at other websites to see what people thought caused the reaction to happen. Now, based on that research, they were able to form a hypothesis or hypotheses. And remember, a hypothesis is an educated guess based on observations that can be tested. Now, something is not a hypothesis, it cannot be tested. So, for example, a lot of scientists have problems with something in physics called string theory because it's really, really hard to test. String theory is basically what happens not in 1 or 2 or 3 dimensions, but in 11 dimensions. So it's really hard to have hypotheses in string theory. The next thing the Mythbusters did is they performed actually a few experiments so that they could gather data. So one thing they did is that they tested the reaction with Mentos in just carbonated water to see if it was just the carbon dioxide in the soda that was causing the reaction. They tested the Mentos in other ingredients of the Diet Coke to see which ingredient could possibly be causing the reaction. They also tested Mentos that had a coating on them to see if it was maybe the surface of the Mentos that was causing the reaction. And from this, they wrote down what they saw, and that counted as gathering data. Now, once they did all these experiments, they were able to form conclusions based on what they found in their experiments. And the last step, which students often forget, and it's a very important step, is to communicate. And the Mythbusters communicated the results by showing the episode of Mythbusters on the Discovery Channel. Now, one thing I'm going to ask you to think about is, which step do you think is most important? And this is one of those questions where there's not a right answer. Your answer is right as long as you can support it with evidence. Now, we use the scientific method pretty often in real life, if you think about it. One example would be fixing a car. So last year, on my drive out to Colorado, my car started overheating. So when I noticed the needle going above where it should be in the temperature, that was me observing something. Then I stated the problem when I called up my dad and told him what was going on. My dad is pretty good with cars, so he came up with a hypothesis about what it could be. He thought maybe it was loose hose. Then I took it to a car place, and the guy fiddled around with some hoses and saw that one was loose. So let's talk about this. When my dad thought that it was one of the hoses, that was him forming a hypothesis. When I took it to the mechanic, that was the mechanic doing an experiment. And the mechanic found that one of the hoses was loose. So that was the conclusion he came to, and he communicated those results to me. Now, I would definitely count that episode as the scientific method. However, you'll notice that there wasn't really a research step. I guess you could count me calling up my dad as research, but my dad didn't have to go on the internet or go into a book to figure out what it could be, because he already had knowledge about that. So even though that step was sort of skipped, I would definitely still count that as the scientific method. Another example would be figuring out which allergy medication works best. This will be another example from my daily life. I do suffer from allergies, and I needed to figure out which allergy medication I should use. So I observed that I had itchy eyes and kind of a runny nose and a sore throat. I stated the problem. The problem was that I was uncomfortable and wanted to feel better. I probably stated that to my mom. I then did some research about what allergy medication I should try. I believe I looked at Benadryl, Zyrtec, and Claritin. Now, I didn't really form a hypothesis about which would work best because I didn't really know. So I sort of skipped that step and just went right ahead to try the different allergy medications. So maybe for a week I tried taking Benadryl, and then for another week I tried taking Claritin, and then another week I tried taking Zyrtec. So that would be the experiment part. And each time I took the allergy medication, I would observe how, if it made me feel better, if it made me feel groggy, if it kept me awake. What I found was that Benadryl made me really groggy, Claritin kept me awake, but Zyrtec seemed neither to keep me awake or to put me to sleep. So the conclusion I came to was that Zyrtec would be the best allergy medication for me. I then communicated those results to my mother. So again, steps were pretty much done in order, but we did sort of skip the hypothesis step. Even though that's the case, it would still count as a scientific method. Now, one thing I'll want you to think about is how you use the scientific method in your daily life.